The defeat of the British Expeditionary Force in France in June 1940 proved a sobering lesson for British tank crews. It became clear that their equipment was unsuited to modern war. On a battlefield saturated with anti-tank artillery, light vehicles with thin armor that protected only against bullets had no chance of surviving. Even the heavier infantry tanks turned out to be much more vulnerable than one would have liked. Tanks armed only with machine guns could be written off immediately. Tanks with guns proved more useful, but were by no means ideal. It was essential to get new machines into production as quickly as possible. The enemy threatened to cross the channel and catch British tank crews unprepared and without equipment. Thus began the story of the tank known as Churchill I's. Work on the new vehicle began in July 1940. The A-20, which had been designed as a replacement for the earlier Matilda, looked rather outdated compared with German opponents, but there was a reluctance to abandon the concept entirely. Harland and Wolff nevertheless built a prototype, but a host of complaints had already accumulated about the tank. One of the main problems was the insufficiently powerful Meadows DAV engine. Engines in British tank construction were generally a headache at that time. The Army would not spend money on developing new tank motors, believing that, if necessary, it could take a ready-made engine already produced by industry. That is what happened. Vauxhall proposed a replacement for the temperamental Meadows DAV, the Bedford Twin-Six. In fact, it was made up of a pair of 6-cylinder engines produced by Vauxhall's subsidiary Bedford, which had proved themselves on lorries. The idea was so popular with the military that Vauxhall received the entire contract for the new tank. The new engine did not solve all the problems, and it was decided to stop development of the A-20 and begin designing a new vehicle. Only the general concept of the A-20 remained in the new design. The decision to design a new tank was rather controversial. Vauxhall had not previously undertaken such tasks, although its engineers did have some experience in mechanical engineering. The customer did not impose strict requirements. The vehicle was to have a turret for a 3-man crew, a maximum speed of 16 miles per hour, and an average speed of 12 miles per hour. The most important point was that production of the new tank had to begin in 1941, even if only in small numbers. Reliability was not discussed at all. Gradually, the outline of the new machine, designated A-22, took shape. The designers intended the tank's armor and armament to surpass its predecessor, but a problem arose with the latter. The planned 57mm gun was undoubtedly more powerful than the 40mm gun fitted to British cruiser and infantry tanks of the time, but work on the mounting for it was lagging. By May 1941, the mounting for the new gun had been developed only for the Crusader, and even that remained so raw that the designers doubted the development would be completed successfully before the Crusader was withdrawn from production. Even a successful development of the mounting did not solve all the problems. Production of the gun was not expected until October 1941, while tanks had to be built immediately. The use of a triple mounting with a smaller caliber gun, a howitzer, and a Bisa machine gun was also discussed. Since such a mounting would also have to be built and tested first, tanks were built with a proven gun in the turret. As the A-22, by then already named Infantry Tank Mk IV, was positioned as a universal tank, the vehicles also received howitzers in the hull. A similar solution had been implemented on the French Char B-1, but the British layout proved slightly less outdated. A dedicated gunner, not the driver, served the gun, and the gun was traversed horizontally without turning the whole tank, albeit within a limited sector. Because the 3-inch howitzer was considered a rather specialized weapon, the British decided it was not worth fitting it to every tank of the new type. Therefore, alongside Infantry Tank Mk IV, a version called Infantry Tank Mk IV was created. On this vehicle, the howitzer in the hull was replaced by another Bisa machine gun. These tanks were fitted with a slightly different glacis plate. The tank armor was designed to give reliable protection against a 2-pounder gun at point-blank range. The armor requirement reports included penetration tables for the 20mm gun Madsen and the 14mm anti-tank rifle boys. This hinted that the designers did not intend to send the vehicle to frontal attacks against 88mm anti-aircraft guns. For a heavy tank, this was rather little, but armor thickness could not be increased indefinitely. The designers decided that an overall thickness of more than 3 inches would lead to excessive weight growth. Thus, the frontal armor was made up of several layers. The main plate, 2.5 inches thick, was bolted to half-inch steel plates, which in turn were fixed to a frame of non-armored steel. Such a cunning construction was needed so the tank would not fall apart under fire, because even insignificant deformation of the outer plates, even at an impact as far as 6 inches from a bolt, could cause a nut to shear off. Tests showed that this construction could withstand a hit by a 2-pound armor-piercing shell from a distance of 400 yards. On the other hand, even a very close hit did not lead to bolt failure. Working with rolled armor of that thickness had to rely on shipbuilding experience, of which the country had sufficient reserves. The roof and the floor of the fighting compartment were 3/4 of an inch thick. The roof and the floor of the engine compartment were 5/8 of an inch thick. The armor of the driver's sighting device was 3.5 inches thick. The driver could open the hatch with the sight for better observation while moving, and at the start of firing close it and observe through the triplex. Under heavy fire, the triplex was covered with a shutter. In that case, the driver could observe only through the periscope. Such a shutter would have to be used even when fired upon by rifles and machine guns, because bullets ricocheted from the sloped glacis into the face plate of the turret support. Since the periscope could be put out of action quite easily, the shutter was made so that if its mountings were destroyed, it would fall away rather than stick in place. It was better to accept the vulnerability of the driver mechanic than to leave him blind. A large hatch measuring 9 by 12 inches was designed so that it would remain in place if its hinges were destroyed. 2 cutouts were also made in the glacis for the howitzer and the gun sight on the Churchill Weim, or a single cutout for a machine gun on the Churchill II. The gunner had neither a hatch nor a triplex. He could observe only through the sight or through a periscope. Because of the complex shape of the frontal plate, it was proposed to cast it, but there were no works in Great Britain that could cast such a part in the required quantities. The side armor was made from armor plate 2.5 inches thick. The sides contained rather large openings for evacuation hatches measuring 22 by 15 inches. Like the driver's hatch, they were not supposed to fall outward when their hinges were destroyed and were equipped with an inside release system so that jamming would not doom the crew to death. A small pistol port hatch was provided in the center of the hatch for firing a submachine gun. The hatch and the hatch lip were inclined at 8 degrees through the thickness. Unlike the A-20, which used the old turret from the Matilda, the A-22 was equipped with a newly designed cast turret. Its prototype was produced by the General Steel Castings Company in Chester, Pennsylvania, which is why it was called the American turret, even though the production models were made in the United Kingdom. The turret armor thickness reached 95 millimeters, or about 3.7 inches. There was no commander's cupola. The commander observed the battlefield through a rotating periscope in his hatch. The fully equipped turret weighed 6.5 tons, or about 14,330 pounds. On May 8, 1941, Canadian Brigadier General Worthington was given the opportunity to observe tests of the new A-22 tank prototype. The machine made a strong impression on him. According to the general, the reinforced armor was the right decision. It had already proven itself on the Matilda tanks in battles against the Italians in Africa. The new tank turned out to be faster than its predecessor and easily overcame slopes, craters, and trenches. The suspension and tracks produced so much noise during movement that Worthington even noted, "In battle, such tanks should advance under the cover of aircraft, so the enemy would not hear them in advance." The turning radius of the A-22 varied depending on the gear. In neutral, it could rotate in place. Despite its weight of 83,700 pounds, the new vehicle was easy to control. The armament also impressed Worthington. The presence of a howitzer meant there would be no need to build a second tank variant for direct infantry support. The general was told that the tank was planned to be fitted with a 6-pounder gun. Even at this stage, it was clear that the tracks, which extended forward, would create problems when installing more powerful weapons. Nevertheless, the Canadian general concluded his report with very optimistic words. "This tank has not yet been tested in combat, but all signs indicate that it will perform excellently. Only time will tell whether it can replace the cruiser tanks on the battlefield." The opinion of the British military coincided with Worthington's high praise. Mass production began in the summer of 1941, and the first models rolled out of the Vauxhall factory in June. The tanks underwent every possible test. Armor testing began even before the production models appeared. On May 13th, the cast turret was subjected to firing tests. The trials used 2-pound armor-piercing shells and 25-pound anti-tank shells. The very first shot from a 2-pounder gun, fired from a distance of about 600 feet, hit the curved lower part of the turret and penetrated the armor completely, causing significant spalling within a radius of 3 inches around the impact hole. The second shot from the same distance did not penetrate the armor. Only a bulge was found on the inside, while small fragments chipped off the exterior. At point-blank range, one shell ricocheted, another became embedded without penetrating, while the third and fourth caused through cracks. The fifth shell broke off a piece of armor measuring 3 by 3 inches from a cracked section and shattered against the opposite wall of the turret, leaving a dent half an inch deep. 2 more shells caused additional cracks but did not breach the interior. Hits from the 25-pound gun did not penetrate the armor but bent it inward by half an inch. With a nominal thickness of 3.7 inches, the armor in the impact areas measured from 3.6 to 3.9 inches. The assembled hull was also fired upon, but much later, on June 5th. The tests were conducted on an almost fully assembled tank, except for the machine gun and the sight for the 2-pounder gun. The main goal of the test was to shoot at the most vulnerable parts of the vehicle. Firing at the evacuation hatch with a Lee Enfield rifle from distances between 30 and 75 feet showed that fragments could still penetrate the tank. The farther from the hatch hinges, the higher the chance of entry. Firing at the gun and machine gun embrasures also proved effective despite the external mask. Shooting at the submachine gun port was less successful. At this stage, bullet fragments did not penetrate the tank at all. After the tank was fired upon with an anti-tank rifle, 10 hits struck the hinges of the driver's vision hatch but failed to jam it. The bullet deflectors welded to the sloped front plate also withstood the fire. When the running gear was targeted, bullets pierced the tracks but did not disable them even when hitting the connecting links. Firing at the tank's frontal armor with a 2-pound gun proved more effective. 2 hits merely dented the sloped armor without penetrating, but a third shell struck near the top edge of the plate, deforming it so severely that several rivets were sheared and torn off. Testers noted that welding should be used instead of riveted joints for the hull plates. On the 9th of July, 1941, one vehicle was tested at the Lulworth Artillery Range. It was a short demonstration for the High Command, yet it already began to reveal the new tank's potential. First, the 3-inch howitzer was tested. The new smoke shells performed well. A thick, white cloud spread across the field. An effective smokescreen formed after 20 seconds and lasted 75 seconds. The maximum range with this shell was about 985 yards, roughly 900 meters. Firing from the 2-inch mortar on the turret roof was less successful. Its maximum range was only 104 yards, about 95 meters, and the smoke developed slowly, reaching full density only after 30 seconds. After testing the smoke shells, the gunner fired 3 high-explosive shells at maximum elevation to determine range. The shells reached between 1,206 and 1,233 yards, or approximately 1,100 to 1,125 meters. Following this, the crew closed the hatches and fired 3 more smoke shells to demonstrate the efficiency of the ventilation system. Serious issues appeared when firing on the move. Since the vehicle was still in its early stage of development, the speed was limited to 10 miles per hour. The tank moved across relatively even terrain, yet with a suspension travel of only 5 inches, it rocked violently even under such conditions. Out of 9 shells fired from distances between 823 and 1,094 yards, roughly 750 to 1,000 meters, none hit the target. When the tank moved parallel to the target, the results improved. After 8 shots, testers recorded 6 confirmed and 1 probable hit. The submachine gun firing port was also tested. The crew quickly struck a silhouette of an infantryman placed 10 feet from the tank. The tank then fired high explosive shells into an anti-tank ditch to destroy its walls and allow passage. After 14 shots, the vehicle attempted to drive through but became stuck. It was pulled out and engineers blew up another section of the ditch with 200 pounds of explosives. After that, the tank managed to climb the collapsed wall. The Covenanter tank failed to accomplish the same task. The new vehicle's cross-country ability was also compared with that of another infantry tank, the Matilda. This took place on the 27th of September, 1941. This time the obstacles were anti-tank ditches, 8 to 9 feet deep and 10 to 12 feet wide. They posed no serious challenge for the new tank, while the Matilda became stuck on its first attempt. However, the new machine also revealed weaknesses. The absence of mudguards caused the tank to be covered in mud during movement. It entered the barrels of the main gun and mortar, coated the periscopes, and even clogged the turret ring. At the beginning of September, instead of dull indexes, the tanks received new names. The infantry tank of the fourth model with a hull-mounted howitzer was called Churchill I, and the infantry tank of the fourth model with a machine gun instead of a howitzer was Churchill II. The new names did not take hold in the services immediately, and the old designations continued to appear in documents. According to Winston Churchill himself, when this tank was given his name, it turned out that the vehicle had a multitude of inherent defects. The famous phrase, "The tank that bears my name has more faults than I do," was not uttered by the Prime Minister, but the Churchill did indeed accumulate quite a lot of problems, and they were not only related to the odd arrangement of armament or brittle armor. Let us return to 1940. Sir Harry Ricardo, the inventor of the engine for the famous British rhomboid tank of the fifth model, was no longer engaged in tank work at the start of the Second World War. The talented engineer had good connections and from time to time wrote angrily to one lord or another, complaining about the dreadful state of British tank building. As one might guess, he was most irritated by the absence of a proper tank engine. Ricardo did not like the idea of adapting engines from wheeled vehicles or aircraft, because that would take as long as creating a new design. Most of the time spent developing such an engine would be used to eliminate defects. Ricardo also had many complaints about the Churchill. In 1 year from the start of development, the vehicle's weight increased from 28 to 38.5 tons, approximately from 62,000 to 85,000 pounds. The new engine solved the problem only partially. It had no effect on the reliability of the running gear. The efforts of Vauxhall helped here only marginally. The measured summarily meager track endurance of 20 miles, 32 kilometers, had by October 1941 grown only to 50 miles, 80 kilometers. The suspension suffered as well. For a vehicle of that weight class, Ricardo recommended abandoning springs and switching to a rigid running gear. The Bedford Twin-Six engine also had its shortcomings. Ricardo spoke approvingly of the abilities of his colleagues at Vauxhall Motors, but did not hide the truth. The company had no experience in heavy engineering. The engine turned out to be fragile and unreliable, and when Ricardo's firm was called in to help, it was already too late. The only thing the tank-building guru could advise without radically redesigning the construction was to reduce the engine power to 300 horsepower. That idea found no support. 50 horsepower was already consumed by the water and oil cooling system, and any further loss of power would have nullified any advantage of the new engine over the Meadows Company project. The Churchill also had plenty of problems with the clutch, the transmission, and the lubrication system. Design defects were aggravated by rather low manufacturing quality. This affected the engine's service life. On 20 July 1941, it amounted to only 9 hours. The service life of some units could not be established at all because the tank could not pass any significant tests without constant stops. Replacing the engine proved labor-intensive. At the Farnborough Proving Ground, the process took 6 days. But there were still not enough spare parts available to allow such a luxury. Another veteran of British tank building, Sir Albert Stern, also spoke negatively about the Churchill, but far more succinctly, as he believed the infantry tank of the fourth generation was unfit for combat and already overloaded even with the 2-pounder gun. Lord Hankey, a supporter of Ricardo and Stern in the government, called the Churchill a second-rate tank and at best a temporary expedient. In his view, such machines should be kept close to the coast so that they would not break down on the way to the battlefield in the event of an enemy invasion. According to Hankey, experts estimated the time required to turn the Churchill into a combat-capable vehicle at about a year, if not more. The Churchill tank had its critics as well. For instance, the Director General of Research and Development of the Tank Department expressed his opinion that the tank's design is a response to the General Staff's request to recreate the large assault tanks of the previous war rather than a modern fast tank capable of long marches. Even more complaints arose with the Churchill Mark II modification. The armament, armor, and top speed of the 38-ton giant, 84,000 pounds, only slightly exceeded those of the 25-ton Matilda, weighing 55,000 pounds. Essentially, the new tank carried an extra 13 tons, 29,000 pounds, for no real purpose. However, one must note that Lord Hankey was lobbying the interests of a group of designers with First World War experience, who had created the monstrous TOG-Y and TOG-2 tanks. Hankey's goal was not so much to replace the Churchill with the TOG, as to promote his old company into a leading position in British tank building. Nevertheless, the proposal to halt production of the Churchill tanks did not gain support. Everyone acknowledged that the new tank had serious issues, but among all the vehicles in service, only the Churchill had been developed after the start of the war. The second candidate for a universal design, the cruiser tank Cromwell, was still in the early stages of development, and designing a new infantry tank to replace the Churchill would have taken at least 18 months. Some British officials believed that the Churchill tank had no flaws that could not be corrected. They considered it unacceptable to stop production and keep unfinished machines in warehouses waiting for improvements. Therefore, a decision was made to send the Churchills to army units as they were. Crews were advised to handle the machines carefully and avoid driving at high speeds, so that the tanks would not fail before the designers managed to fix their early defects. The Churchill's reliability did, in fact, gradually improve. In September 1941, the tanks were tested during a training exercise called Bumper. Among many other units, 3 armored divisions and 2 army tank brigades took part in large-scale 4-day maneuvers. According to the scenario, British and Canadian forces were to counterattack German tank units that had successfully established a beachhead, broken through coastal defenses, and advanced inland. In such a situation, the British tanks needed to act quickly and decisively to intercept the enemy formation. But the Churchills did not fully succeed in the task. To preserve the tank's mechanical life, crews were forbidden to use top gear, limiting their speed to 16 kilometers per hour, 10 miles per hour. Despite this, half of the Churchills required repairs during the maneuvers, and by the end of the exercise, 40 of the 54 tanks needed maintenance. After 48 hours, 11 Churchills were still in the workshops. The average distance covered by one tank during the operation was 241 kilometers, 150 miles. The tank's reliability and average range proved much worse than those of the Valentine, Matilda, and Covenanter tanks, which also took part in the maneuvers. On average, the other types covered 362 kilometers, 225 miles, 1.5 times more. In early December 1941, 2 production tanks were tested again. The machines completed a march of 105 kilometers, 65 miles, on a concrete road without a single breakdown. The run was successfully repeated the next day. After lifting the ban on top gear, the average speed reached 22.5 kilometers per hour, 14 miles per hour. On 1 gallon of gasoline, the tanks traveled 1.37 kilometers, 0.85 miles, which was even better than the requirement. At the same time, an experimental vehicle managed 1,127 kilometers, 700 miles, without serious failures. The Vauxhall Company also developed new tracks with a service life of 3,218 kilometers, 2,000 miles. The reliability of tanks was improving both through better crew training and through higher production quality. Out of 22 major defects, by mid-December 1941, 20 were considered corrected. The military established a specific reliability requirement for the vehicles: the ability to travel 96.5 kilometers or 60 miles per day for 6 consecutive days. By the end of 1941, they were close to achieving that goal. The reliability of the new vehicles was promising, but the older tanks also needed to be brought up to that standard. There were quite a few of them. As of November 27, 1941, the Royal Tank Regiment possessed 381 Churchills, 111 of which were already unfit for combat and required major overhauls. The modernization program began to gain momentum at the start of 1942. By the end of January, 50 vehicles were planned to be upgraded, and by March, 700 out of 1,000 tanks were expected to be modernized. According to specialists from the Ministry of Supply, it was impossible to bring the first 300 Churchills produced into combat-ready condition, so they were to remain in the homeland as training vehicles. The service life of these temperamental tanks could be preserved by transporting them on special carriers. There were not enough vehicles in Great Britain capable of carrying a Churchill, but the Americans promised to supply 300 units for that purpose. By the end of 1941, the situation with the Churchill had more or less stabilized. The German war machine was bogged down in the Soviet Union, and the threat of invasion of the British Isles had receded. There was no longer any need to feverishly produce low-quality tanks, and the quality of the vehicles being manufactured began to rise. Although the first and second modifications of the Churchill were soon replaced, no radical design changes were implemented in this family of tanks until the end of the Second World War.